Have you ever looked up at the night sky and wondered, just how far away are those stars? It's a question that has captivated humanity for centuries. Today, we're diving into one of the most brilliant and reliable tools astronomers have to answer that question, the cosmic lighthouses known as Type Ia supernovae. Imagine a lighthouse on a distant, foggy shore. Even if you don't know how far away it is, you know its light has a specific, consistent brightness. If it looks dim, it's far away. If it looks bright, it's close. This is the exact principle behind Type Ia supernovae. These incredible cosmic explosions always, and I mean always, have the same exact intrinsic brightness. They are what scientists call standard candles. So, what exactly is a Type Ia supernova? It's not your typical story of a single, massive star collapsing. Instead, it's a dramatic tale of two stars locked in a cosmic dance. The star of our show is a white dwarf, which is the super-dense leftover core of a star like our Sun after it has exhausted its fuel. It's about the size of Earth but has the mass of the Sun. Talk about compact. This white dwarf isn't alone, though. It has a companion star, usually a red giant. Because the white dwarf is so incredibly dense, its gravitational pull is immense. It starts siphoning or accreting material, mostly hydrogen and helium, from its larger companion. Think of it as a cosmic thief, slowly stealing gas from its neighbor. This stolen material builds up on the surface of the white dwarf. For a long time, nothing dramatic happens. The white dwarf just gets heavier and heavier, compressing under its own increasing weight. But there's a limit. This limit is a magic number in astrophysics known as the Chandrasekhar Limit, which is about 1.44 times the mass of our Sun. Once the white dwarf hits this critical mass, it can no longer support itself against its own gravity. The pressure and temperature at its core skyrocket to unimaginable levels. This triggers a runaway thermonuclear reaction, a chain reaction that engulfs the entire star in a fraction of a second. The white dwarf doesn't just collapse. It detonates in one of the most violent explosions the universe can produce. And here's the key. Because they all explode at precisely the same mass, that 1.44 solar mass limit, they all release a consistent, predictable amount of energy. Every single Type Ia supernova shines with the same peak luminosity, about 5 billion times brighter than our Sun. This is why they are perfect standard candles. When astronomers spot one of these supernovae in a distant galaxy, they can measure how bright it appears from Earth. Since they know how bright it actually is, they can calculate the distance. The dimmer it appears, the farther away it must be. It's like seeing that lighthouse in the fog. The faintness of its light tells you the distance. This technique is incredibly powerful. It allows us to measure distances not just to stars, but to entire galaxies billions of light years away. In fact, it was by studying Type Ia supernovae in the late 1990s that astronomers made one of the most shocking discoveries in the history of science. They expected to find that the expansion of the universe was slowing down due to gravity. But the data from these distant supernovae showed the exact opposite. The most distant ones were dimmer than they should have been, meaning they were even farther away than predicted. The only way to explain this was if the expansion of the universe wasn't slowing down, but was actually speeding up. This led to the concept of dark energy, a mysterious, repulsive force that is pushing the universe apart at an accelerating rate. It's a discovery that earned its pioneers the Nobel Prize in Physics and completely revolutionized our understanding of the cosmos. And it all came from observing these reliable, predictable stellar explosions. From a dying star stealing mass from its companion to a universe-shattering explosion that reveals the deepest secrets of cosmology, the Type Ia supernova is more than just a beautiful cosmic event. It's a fundamental tool, a measuring stick that allows us to map out the vast expanse of space and time. So the next time you gaze at the stars, remember the incredible stories unfolding out there. Remember the cosmic lighthouses, the Type Ia supernovae, that light up the darkness and help us find our place in this vast, expanding, and absolutely amazing universe. Thanks so much for joining me on this cosmic journey today. If you enjoyed learning about these incredible standard candles, please give this video a thumbs up, and don't forget to subscribe and hit that notification bell so you don't miss our next adventure into the cosmos. See you next time.